All right. So, and this one, it says we're supposed to write each system as a matrix equation and then solve using the inverse coefficient matrix. Use a graphing calculator or computer to perform the necessary calculations. All right. So the nice thing is we can kind of, write this out if we want to. And so our matrix is going to be 2, 1, 6, 5, 3 minus 4, 15, 2, 7, 3, 7, 4. 5977. Then we'll have it times x1, x2, x3, x4, and that equals 54, 84, 34, 77. All right. So luckily they say use a graphing calculator. So we have to find the inverse of that matrix, and then we'll multiply it by this, and then we'll get x1, x2, x3, and x4 when we're done. All right. So, and that's going to be whatever that inverse is. And so let's go ahead and do that. So let's go to our calculator. And so matrix, and I've typed in the first one. Now the second one is not going to be too hard. We just come over here and we're going to type it in here. So this is going to be 4 by 1, and that's our 54, 84, and then it was 34, and then 77. Okay. All right, so let's do two things. First, let's find A inverse. So that's A. Inverse is just the oops, not double inverse. All right, matrix, and then we want A. We just want inverse. All right, and then enter. Now, if they tell us to write that down, that's kind of nasty. So let's convert those to fractions. And when we do that, it looks a little bit better because we can write that down, whereas those are kind of non-repeating decimals. And so we need to have that. And so those are going to be the fractions we would have. And so this is one reason why they tell us to use the graphing calculator or a computer to solve this one, because they are such nasty numbers here. All right. And so if we now wanted to find what x1, x2, x3, x4 was, we're going to take and do our A inverse. Let's come back here to A inverse and times B. And so B is 2. And I think it's probably going to still be fractions, so I'm going to add fractions at the end. And so when we multiply, it's going to take this number times that B and then convert it all to fractions. And this is what we get. Negative 59 tenths, 16 fifths, 71 tenths, and 4. So that is the solution to this problem. So if we write down what they had, minus 57 over 1790, then we had a minus 99 over 1790, then we had a 224 over 895, and then we had a negative 187 over 1790. And hopefully that's big enough for everything. And then we're multiplying that by our B, which was our 54, 84, 34, and 77. All right. And then the next row was negative 172 over 895. Then we had 31 over 895, and then negative 77 over 895, and then 158 over 895. And then we had a negative 167 over 1790 and 181 over 1790 and negative 66 over 895 and then 143 over 1790 and then 65 over 179 and then minus let me see, I can't really read that again. Let me switch it back over here. 19 over 179. Okay, that's what it was. Switch back over here. Negative 19 over 179, and then 1 over 179, and minus 16 over 179. And then we ended up with our solution, which was a minus 59 over 10, a 16 over 5, a 71 over 10, and then a 4. And that was our solution to this system of equations. So much easier than if we would have had to do elimination or whatever to get this, and a lot easier than trying to, get it any other way. So getting our calculator to find our inverse, telling it to multiply then by our b to get our final answer was very simple in this case. So those are the nice kind of problems when you get to use your calculator strictly. All right, let's stop with that and we'll come back for another one.